moving objects, how fast they move and where they are at a moment was what Newton was actually looking at when he developed calculus. So it is historically and also logically just natural that we're going to be looking at physics a great deal, in particular the kind of physics that led Newton to develop calculus. And he was looking at the speed or velocity of free-falling objects. So two things that are tricky here. First, let's talk about the difference between speed and velocity. Velocity is a more complex concept because velocity includes direction. Speed, on the other hand, just answers the question, how fast? So suppose we have a car that's going 50 miles per hour north, and we have another car that's going 50 miles per hour, what is this, east. Now these two cars then have the same speed but not the same velocity. Alright, so that's one thing. The other is because of this definition there are going to be other differences that we will see later. So the other tricky thing is the word average, because it's a little bit misleading, because it tempts people to just add and divide by 2, but that's not what's going on. Let's first discuss average speed. Usually V is for velocity. I don't know how speed is denoted. Sometimes people denote average by a bar over it. That looks weird. This would be average velocity. But I'm just going to use a little index. The average speed is defined, the total distance traveled divided by the time it took to travel that much. So it measured in miles per hour, or meters per second, or kilometer per second. But it's a length divided by a time unit in physics. I think the concept of average velocity is pretty intuitive. Imagine that we're taking a trip. Sometimes we're going fast on the highway, sometimes we take a break. But if we want to know on average how fast did we go, this is what we would do. So let me show you why the word average is a little bit misleading. Suppose we have a trip that has 2 parts, and say both parts are 60 miles long. And let's say that we complete the first part with an average speed of 30 miles per hour, and the second half with an average speed of 20 miles per hour. Even though we have the same distance, if we ask what is the average speed for the entire trip, the answer will not be, well, why don't we just add 30 and 20 and divide by 2? It's not going to be 25. Let's just see what the definition will bring us. So we're going to need the total distance. Well, the total distance traveled is 120 miles, right? Now here we need times, but we don't have times. We just have speed and distance, speed and distance. So we have to figure out how long did it take to travel the first part, how long did it take to travel the second part. So let's do that. The distance, provided that the velocity is constant, is velocity times time. So we can solve for time here. Time is the distance divided by the velocity. So in this particular case, it's 60 miles per 30 miles per hour. I want you to watch the unit, because the units can tell you when you go off the trail. Miles divided by miles per hour, to divide is to multiply by the reciprocal, so we multiply by hours over mile. Miles cancel out and we're left with hours. But that's kind of common sense, right? If we had a speed of 30 miles per hour, that means we covered 30 miles in 1 hour, 60 miles in 2 hours. So this is no surprise. Now we're going to do the same in the second half. I want to leave the computation and the units for you, because 60 over 20 is just 3. So this is going to be in 3 hours, right? This speed means 20 miles per hour means 20 miles in 1 hour. So 40 miles in 2 hours, 60 miles in 3 hours. So to apply the definition, the total distance traveled divided by the time would be 120 miles divided by 5 hours, which is not 25, it's 24. In higher level mathematics, you will see that there is not just one average. There are all kinds of different averages. By them we call them means. What we call regular average is called arithmetic mean, and this one is an average. It's not the arithmetic mean. This is another one, and actually this one came from physics. This is one example where this type of an average shows up. So you will have to apply the definition, which is the total distance traveled divided by the time. Okay, so that's about the word average and how it is misleading. Now let's see the difference between speed and velocity. Okay, so let's see an example, actually 3 of them, that will illustrate the difference between speed and velocity. So suppose we have a trip that has 2 parts. The first part is 50 miles long that we cover with an average speed of 25 miles per hour, and part 2 is 120 miles which we cover with a 30 miles per hour average speed. And there are 3 different cases, but they both are built on these 2 pieces of information. In the first example, we're going to travel 50 miles and then 120 miles in the same direction, let's say east. In the second example, we're going to travel first 50 miles towards the west, and then we turn around and travel 120 miles to the east. And in the third example, we're going to go 50 miles north and then 120 miles east. Now let me start saying that in all 3 cases, the speed is going to be the same, because the speed is interested in sort of how much work was done, how much traveling occurred. And in each case, there was 170 miles during how much time. So let's first figure out how much time these 2 parts took, and that's going to be true for all 3 cases. If we travel with 25 miles per hour, it's going to take us 2 hours to cover a 50-mile trip, right? And this one would be 4 hours. The handout has detailed computations with the unit. If you need more on this, just look it up there in the handout. So the speed in all 3 cases, 170 miles divided by 6 hours. That is not going to be very pretty. 170 divided by 6, 28 point. This bar means 3, never stop. That sort of makes sense at this point, right? We're still between 25 and 30, which sort of feels right. Okay, now the average velocity will be different in the 3 cases, because the numerator in average velocity is not the total distance traveled. It's the displacement. So V average is displacement divided by the time. You might wonder, what is the displacement? Well, it is the change in location. And that's not the same as the distance traveled, because if you look at the second example, the total distance traveled is, well, first we traveled 50, then we traveled 120, that's 170 for speed. But change in location means, well, we started here and we ended up here. That means that, all things considered, we just went 70 miles east. That's the displacement. So 170 miles is the total distance traveled. The displacement is just 70 miles east. So in the first case, the total distance traveled is the same as the displacement. So in the first case, we would have this exact same computation. So the average velocity in this case is just 28.3 miles per hour. But in the second case, and the other thing with velocity is that when someone asks, give me the speed, you just have to say 50 miles per hour. But if velocity is asked, you have to also specify the direction. So we'll see that. So in the second case, the displacement is 70 miles, and that is what we divide by 6 hours. Also not so pretty. So we have 70 divided by 6, 11 and 2/3. This sort of made sense because the first part and the second part was sort of working against each other. That's why we have and it's to east. So the average velocity is 11.66666 miles per hour towards east. So the third case is when we have 50 miles of traveling north and then 120 miles east. So the displacement would be, well, we started here, we landed there. What is the simplest motion that explains that change? That's the displacement. So if we travel 50 miles north and then 120 miles east, that is the same but less efficient than just going straight along the hypotenuse of this right triangle. And so when we apply the Pythagorean theorem, we're going to square this, add and take the square root, right? We're going to have 130 miles. And if someone was wondering, so let's see first the numerical part of the velocity, so how fast. Now we're talking about 130 miles covered in 6 hours, and that's 21 and 2/3. Now that's just the speed, but if we have to give a direction, one convention is to specify this angle. Or you can say, well, this angle to the, we can say this is the east direction, we can find this angle and then say, well, that much from the east. But I believe if you start from the east direction and this is the positive direction, then you don't even have to say anything because that's sort of the default. So we give the direction by specifying the angle. Now here, if I call this angle alpha, then our angle is going to be 90 minus that, right? These two add up to 90. And for alpha, if you use trigonometry, tangent alpha, tangent is opposite over adjacent. So it's 120 divided by 50, or 12 over 5, or 2.4. And then we have to ask the calculator, don't have here. So when we ask the calculator, alpha is what? So the tangent alpha is 2.4. So when we ask the calculator, alpha is what? So the tangent alpha is 2.4. What we enter is this. This is the notation for inverse. That's going backwards. This is how we ask the calculator, give us the angle alpha so that the tangent is this. When you're using the calculator and you're going for an angle, make sure to know what measurements you're in. This little DEG shows that the answer is in degrees. So we get 67 and change. Looking at the picture, that sort of makes sense. So it's 67.3801. If we're dealing with approximations, i.e. decimals, if the rounding is not specified, go at least 3-4 digits. We can measure that much, so it's worth it. It does matter. Then our angle would be 90 minus that, so it's 22 and change. So there is the velocity. This is the angle. 0 degrees is 0 degrees is the positive part of the x-axis, and the positive direction is this way. So the angle 22.61986 describes exactly the direction. I should have said this earlier, but two objects have the same velocity if they have, first of all, the same speed. Second, they travel in the same direction, which means they either travel along the same line in the same direction, or they are traveling along parallel lines in the same direction. Think about it this way. Two cars with the same velocity can never collide. It's impossible. Two cars with the same speed, easily. There's one more thing. Our first example was about this trip. 60 miles with a 30 miles per hour average, and then the same distance with a 20 miles per hour average. So imagine that speeds are the same, but now we're talking about a round trip. So we have a speed of 30 miles per hour on the 60-mile trip, and the same 60-mile trip backwards is with an average speed of 20 miles per hour. If we have this sort of a round trip, then again the average speed is the same because the total distance traveled is still the same. Now the average velocity is 0 because what is the displacement? We went from here to here, right? So the displacement, we landed at the same place. So the displacement is 0, therefore the average velocity is 0. I think we covered everything. Let me know if you have any questions. Thank you for watching.